Alrighty folks, in this video I'm going to go through a quadratic formula example. It's going to be an easy one. Alright, so the quadratic formula is listed right here. It's x equals the opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2a. And so a, b, and c are listed in our quadratic here. So a is the leading coefficient, b is the coefficient of the second term, and c is the last term. Okay, so you use the quadratic formula when you're solving quadratics, and you can't solve it in a simpler way. So in this easy example, I wouldn't have to use the quadratic formula in this one. What I could do is I could just factor this one. But I'm going to use the quadratic formula because it's an easy example. We'll get some easy answers here. We'll get some whole numbers, integers, that will make it easier to work with. So sometimes it can be helpful for students to write this, but identifying a, b, and c first. So a equals 1 because it's 1x squared, b equals 5, and c equals 6. And all we're doing is we're plugging it into this formula. You might want to memorize it. All right. So if I'm plugging that in, and by the way, I only do this when it equals 0. If it equaled another number, it's not in standard form. So we're really just finding zeros here, or roots, finding the x-intercepts, right, on a graph. Okay, so we've got x equals, it'll be the opposite of b, so negative b, negative 5, plus or minus the square root of, and I'm just copying that formula, b squared, so that's going to be 5 squared, and I'll use parentheses when this is negative, minus 4 times a, which is 1, times c, which is 6. All of that over 2 times a, which is 1. And then I'm going to simplify. All right. Let's see if I can zoom in a little bit for you folks. Maybe you can see this a little bit better. All right. So simplifying over, I still have negative 5, plus or minus. So that plus or minus used to confuse me when I did it. This means negative 5 plus some number, and then we're going to do another one where it's negative 5 minus a number. And so we're doing that all at once just to save time. So inside this, or underneath this square root, is 5 squared minus 4 times 1 times 6. And I typically will take a calculator myself, and I'll just type all that in. The 5 squared minus 4 times 1 times 6 all at once. That'll make sure I reduce errors as long as I'm typing it in correctly. So, or I could do it in my head. 5 squared would be 25 minus 4 times 1 times 6. 4 times 1 is 4 times 6 is 24. So this is 25 minus 24, which is 1. This is why I said it's an easy example. And on the denominator, I have 2 times 1, which is 2. So let's go down to this next line here, making sure you can still see. All right, so then we have negative 5 plus or minus the square root of 1. Well, what is the square root of 1? 1. And it's at this point when we want to break this off into two different problems. So this actually becomes two different things. Okay. You won't always see me do this, but this is really just x equals negative 5, the plus version of 1 over 2, and then x equals negative 5 minus 1 over 2. So hopefully this is refreshing your memory. That's what that plus minus meant. It's really just two different problems. We're going to have two different solutions because it is a polynomial of degree 2. Right? So negative 5 plus 1 is negative 4 over 2. Right? And so that answer is going to be negative 4 divided by 2 is negative 2. And then negative 5 minus 1 is negative 6 over 2. And that's negative 3. So I've got two different solutions. X equals negative 2 and x equals negative 3, which is not surprising. If you were to factor that original quadratic, you would have gotten factors that are x plus 2 and x plus 3. Right? And then if you were to use the zero product property, you'd get these solutions. These represent where the graph crosses the x-axis. So these are real numbers. They actually exist, and you could see them on a graph. Next up, we're going to do a video on a medium example, and then there will be one more on a difficult example.